this computer. All right. Thanks everyone that is here. Gonna share just some slides before we actually start talking about the book. So welcome. This is AI from scratch for those that you don't know or were part of the previous study sessions. Yes, AA from scratch is a study group, something that came pretty organic uh, about 4 months ago from this tweet that I was like, I bought the book, this book, you've probably seen it, and I wanted to read it, but I didn't want to read it alone. So I basically tweeted that, hey, who's up to meet every week, talk about each chapter, and basically read the book together. And turns out a bunch of people. So the last 4 months we've been reading. We were reading this book by Sebastian Rosca, uh, and it was great. At the end, we even met Sebastian, so it was pretty cool. Today, uh, we start with AI Engineering by Chip. Uh, for those who don't know, Chip is a pretty famous uh, machine learning engineer and AI engineer now as well. And she has written two books on about ML. This one and the previous one was designing machine learning systems. So yeah, this is what we're gonna be focusing on the next following weeks. So how does the study group format, like how does the study group works? Is that we meet every Sunday at 2 p.m. UTC. So it's probably different time for everybody in the call. In my case, it is 8 a.m. I know that people in England and Europe is later in the day, but yeah, we meet every Sunday. Um, we discuss ideally one chapter per week. Sometimes some chapters might overlap because some chapters are longer than others, but that's okay. The preparation, the idea is that everybody reads during the week the chapter, and then we discuss on Sunday. Each discussion will have a chapter, or a chapter leader, a discussion leader, that is a volunteer. So, for example, today I'm gonna be the discussion leader. I'll do my best, uh, but of course, during the discussion that I will try to lead, you are welcome to make any questions. You're welcome to make your comments and enjoy in a group discussion. That's the idea. The length is 90 minutes, might be less, ideally not more, to just keep it keep keep the time limits in control. So yeah, today we're gonna this date is update is not dated because last week I was sick, 23rd, so we need to move just things for on this later. But the plan is 10 chapters, 10 weeks. We might not the plan. It might take us a couple of weeks more, but that's the idea. We're gonna start today with the first chapter, that is the introduction chapter. It covers a lot of ground and it kind of talks a little bit about everything else. So this brings me to another question. Be mindful about your mic. If there's like some background noise, uh, let me just mute. Okay. Yeah, be mindful about background noise. If there's some noise happening that is not relevant to the discussion, I'll just mute you politely, but just that just open the mic when you want to ask a question, uh, and then we're okay. So next week is gonna be about understanding foundation models. The leader is still to be defined. That's one of the topics on the agenda. So by the end of the call, close to the end, I'm gonna ask who's who's willing to be the discussion leader for next week, and then we're all set for next week. I'm just gonna make a quick note so I don't forget. All right. Any questions about the study group format? About uh, anything in particular? Yeah. No. Much maybe something that you would like to add this because I am asking Mash because this was like the book format idea that at the beginning of the previous book that we were reading, Mash brought it to our attention. It was a great idea, so maybe you have also inputs.
Thank you, Santiago. Hello, everybody. I'm Mash, and yes, this was I shared a link uh, to Chip Huyen's uh, latest podcast, at least one of the more recent ones. I found several really good podcasts that Chip's done. They're all available on YouTube, including the one that I linked on our Discord channel. She's a brilliant engineer. I had been using her approach and her methodology for my work as an applied data scientist, AI engineer, the strong operations and strategy background, which is what I do. Um, and so she blogs about a lot of what she put into this book. What you'll find, and what I've done before with study groups, like what we just finished with Sebastian's book, where we walk through not only the chapter, but also the notebooks to run it and get a very strong intuitive background equally amongst all of us. Um, so that was not only an amazing experience, the opportunity to take Chip's book and to be able to, which is less coding, but much more of that intuitive understanding, um, is something that will be foundational, in my opinion, especially for how large language models are being developed and how they're being applied for you to be able to talk to it intelligently in the way you work and so on. This space, you don't need to hear this from me. It is evolving at an immensely rapid pace. Everything was sort of US centric until back in early December. This one hedge fund open sourced and released DeepSeek, and I'm sure you've seen the impact of that. All it is better math. And so, and now we've got, again, the race to build better and better foundation models, but really it's about how do you integrate it with your data and put it all together. And so here we are. This book is probably, again, I'll highlight, is one of the most foundational learnings out there. Less code, more solid understanding of AI. So without further ado, let me hand it back to Santiago to help us get started. And let's just get started. Let's get on this journey.
Right. Carlos, your hand is raised.
Yeah, the only thing that I wanted to say is that after the Sebastian's books, which was actually a lot of code and a lot of putting our hands on notebooks and all of that, I read the first chapter of this book and I found that it's as Mash was saying, it's a lot more strategical and a lot more about thoughts around concepts and when to use things, when not to use them, etc. So I was just wondering if it might be a good idea to just suggest that if someone sees that we're going to be talking about something and they know about it, we're going to have like a chapter about RAG, for example, and we have people who works a lot on RAG. So maybe either they can just volunteer for the chapter or just volunteer for additional slots, which I think that it may be interesting for just showcase those things, because otherwise I think that it's going to be maybe too theoretical, I guess. So it was
Yeah,
just suggestion in case anyone wants to not do a chapter, but just gave us some examples or something like that.
yeah, yeah. That's a great idea because indeed the book, as you said, is something foundational that is not it's not centered in tools or the math behind the stuff that we're gonna cover. So yeah, if you're really work with, for example, evaluating models, systems, then please you're welcome to take on to lead these discussions or just bring those topics and examples. Uh, last time, for example, with the Sebastian book, the book didn't cover in the technical aspects about RAG, but we had one volunteer that gave us a full session about RAG, for example. So that was great. So yeah, but yeah, the book starts as probably many new AI books start. That is talking about ChatGPT. And ChatGPT is the thing that made LLMs popular to the general public because it was basically an explosion. Yeah, yeah, an explosion of new possibilities. And basically, what they did is that lowered the barrier for developers, for people, for other machine learning engineers to build AI applications. Before, you had to go and get your data, develop your models, figure out how to figure out what is the best way to evaluate them, figure out how to put them in production and make it available for people to use them. And nowadays, since ChatGPT and since the release of specifically the ChatGPT API, you don't need to know all the math. You don't need to understand what are the attention mechanisms. You don't need to know algebra to have a generative model that talks to you like one of the science fiction movies. Nowadays, if you know software engineering, you can make a call to ChatGPT and basically start building stuff that solve business problems and people's problems. So yeah, this is why as well something like a field like AI engineering was formed. In the preface, what else do we talk about? We talk about that uh, that many of the principles that were required to build machine learning applications are still needed to build AI applications. So some of the old stuff is still relevant, like evaluating machine AI models, machine learning models. But other stuff are not that important. For example, in machine learning, in traditional machine learning, um, getting your data labeled is very, very important. If you don't have a data set that is taken from your business use case, like from the distribution of the business use case that you want to solve, and you don't have it labeled labeled by experts, you basically don't have anything to train a machine learning model. Assuming it's a supervised machine learning problem, right? With AI, with AI engineering, the data set is still relevant, right? But now it is there are companies like ChatGPT, like Google with Gemini, Anthropic with Claude, that they collect the data set, right? For us, they collect these massive data sets that are coming from all over the internet. Uh, they train these foundation models that we didn't have for machine learning engineering, but we now have this idea of foundation models in AI engineering that we're going to talk about that in a second introduction, but also it is the topic of the next chapter, like understanding what a foundation model is. So they train these foundation models and they make it available for the rest for the public to use. Then we as the public, we can use it as it is. We can fine tune it if it is an open source model, or we can do some prompt engineering. Those are the new things. The old things are still relevant, like evaluation. But yeah, so it was kind of a paradigm shift for machine learning engineers, and it was also a great opportunity for many developers, many software engineers that were not exposed to machine learning to now create tools that has AI, that sparks AI. So yeah, this book ideally helps us understand the engineering workflow for building these kind of tools. So from understanding if the problem we want to solve, if it is a problem that can be solved with AI, or if it can be solved with just traditional programming, understanding how to evaluate the solution, understanding what are kind of these ingredients that I need. Do I need to fine tune it? Can I get the problem solved just by prompting? Do I need to RAG? How do I evaluate? What do I do with hallucinations? And etc. So that's the principle of the book and the idea. As we were saying, this book is not it's not about tooling, it's not about tools, it's not about code that much. It is about the principles to build this kind of applications. Yeah, this is a bit more about the preface. I don't know if anybody has anything to add, any comments. No? Yeah, this is about preface. Uh, there are some I haven't looked at codes yet, but Chips makes available some scripts. Maybe we'll see them later on. So that's also great. Something funny that I noticed is that if you go to Chips uh, repository on the book and you go to study notes, here's our reading here from scratch reading. So it's fun because Chip now knows that this exists. So we'll do our best to, uh, to invite her to join one of our final sessions. Let's see. I can't promise anything, but it would be cool. Then, how do I move to the next chapter? Just let me move these some controls that are blocking me. Okay. So yeah, now starting with the first chapter, it is it as I was saying, it covers a lot of ground. The first chapter kind of talks about everything that we will discuss in the book. Um, it starts talking about pre uh, pre ChatGPT and post ChatGPT, and one way that Chips describes post ChatGPT or post 2020, it's the scale of these large language models. Before, like modeling language is not something new, right? Many of you might know that there was this, no, it is still exists, but there is this field called natural language processing. I think around like me see a date around here. I don't remember. Yeah. So yeah, large language models were discovered like centuries ago, and many people have worked a lot to try to model language, try to model human language and make computers understand it and make computers talk like humans. This has been a long time task and a very difficult one, right? Because imagine you can only process data as rows and columns, and now you want to give the computer the power to just understand words. Crazy, something crazy. Um, and we used to have this kind of methods uh, to process language. But post 2020, we had tools like ChatGPT, Google, Gemini that now process data sets of billions and billions and billions of tokens. And we now have a new word that is called token. Uh, that is, that we're gonna see. We're gonna talk a lot about tokens, but it's basically the unit that computers, the language unit that computers process. Then post 2020, it also come this idea of model as a service. As I was saying before, you had to have a specialized team to develop a model to then use it in your application. Now it is a matter of just an API call, and it is a model, and you pay for, I don't know, for requests and stuff like that. And yeah, then we have the definition of AI engineering, that is this process of building applications on top of models, on top of these large language models. So then we have the chapter, and it starts kind of from a historic perspective. So we go from language models to large language models, and then after large language models, we're gonna go to, if I see it here, yeah, from language models to large language models, then from large language models to foundation models, and then from foundation models to AI engineering. So Chip, um, this is how she formats the chapter, and we kind of see that, yeah, this thing is not new. A language model, what it does is basically it encodes a bunch of statistical information about one or more languages. So the most popular one that we talk about is English, but there's large language models in many languages. And basically, you can think of them and as a word completion model. So the main task is having examples like my favorite color is, and then asking the language model or training a language model to predict uh, this blank space, to predict what to put in this blank space. So humans know that probably the word blue should have higher probability than the word car, right? Because we humans learn that the word that colors are blue, yellow, green, red, etc. But they are not, like car is not a color, bus is not a color, school is not a color. But computers, they don't know that, right? So how do we encode this information uh, in the computer and make them for them like available to just predict this next word? So that was the whole research effort. All the efforts were put into finding a good way of how to make machines predict the next word. And it's a uh, pretty simple principle that is pretty crazy actually. That uh, by solving this principle, we just got a lot of applications. So we know now that we got to a solution, a reliable solution, a nice one, um, for this task. And this allowed us now to have conversations with chatbots. It allows us to make chatbots to translate from one language to another. It also allows for summarize documents, etc. So everything coming from these simple kind of examples of completing sentences. Let me go back to here. Any questions, any comments, please interrupt me. The idea is that we also kind of interact. So yeah, maybe does anybody remembers their first time interacting with ChatGPT, for example? What what did they, what did you thought about it? Nobody? Yeah. The my first time, uh, I was a bit excited actually the first time because I was exposed to NLP models for a while, and I worked on them on some projects, and I was every time very not a I wasn't a huge fan of chatbots like these ones, these chatbots that you typically look in like a customer service chatbots that they just like they don't understand your actual question and you are always like human, human, human until a human comes and joins the conversation. So the first time I saw ChatGPT, I thought it was gonna be like a version of that, maybe just slightly better, but that's it. That's what I thought. Then I saw that I was wrong, and it was pretty exciting. It was pretty exciting. Of course, there was a lot of hype around it. There still is, um, but the things that we're now building, I'm pretty sure it surpassed everybody's expectations. Uh, yeah. What else? We talk about that tokens are these units that models take. So you can see here a visual example about how tokens are separated in a sentence. This process is called tokenization. There was also something not new. Tokenization was a technique that was used in language models. Um, yeah, we can go and talk about why tokenization is important. But basically, it breaks words in an intelligent way, and this allows us to have fewer unique tokens than unique words. So it makes it more efficient for the model to model these units. Then we review. Yeah,
Santiago? Yeah,
yeah, Julian.
sometimes I have the doubt like about the white spaces in the tokens. For example, in the phrase
Uh-huh.
that was up there.
Yeah,
Um,
here.
like is the is it is the vocabulary literally every token and also the same token but with the white space, or how does it handle like that part? I never got
Mhm.
that part clear. Like, for example, there, feel, or wait, or awesome, or any of the, like, I'm not sure exactly how that works.
Yeah, that's a good question that I probably don't have a good answer, but it's funny that yeah that now you mention it because for example every word has a white space at the beginning, but for example I doesn't. Um, Probably different shades between words tokens that are likely to appear in the beginning of the sentence, uh, and others are that follow.
Because
So.
I would have expected like the that sentence to be broken up, like what white space to be a different token, like different from the word.
Mhm. Yeah.
But I'm not.
Yeah, and for example, and like the negative
Mhm.
thingy,
Yeah.
doesn't have a white space, right? Because probably in the vocabulary you never see a white space between this apostrophe and the T. So yeah, I don't know. I mean, I guess was trying choice to use white spaces. So then you know when to break uh, words, when to stop one word and continue with the other one. But yeah, it's a good question. I don't have a good answer.
That up.
Right. Yeah, then we discussed about masked language models and about autorecursive language models. Just a brief explanation, masked language models. Kind of the same example, right? But now the white space is in the middle, and we want to complete this by having the context of what is previous the white space and after the white space. So uh, these type of models have information from before and after. And autoregressive ones only have information from the before. Um, Autoregressive ones are more popular. Why? Because they are about generative AI, right? You don't know what's next. And masked language models are great for other type of tasks, like I don't know, sentiment analysis, for example. You want to have all the information in a paragraph to to do sentiment analysis stuff. I saw I saw that someone had their hands raised. Yeah. Or- yeah, I see Mesut.
Sorry, yeah, I tried to answer this question, a question of Julian. I
Uh-huh.
mean, about white spaces. Of course, this each segment on this image, which you showed before, I mean, each segment of the sentence, this sentence is highlighted, yeah, with different colors, and it means actually they are representing individual tokens. And these white spaces play a crucial role. The reason is they are often treated as separate tokens, but not always. Maybe, I mean, it is always a part of a tokens, small tokens. But the models, we know actually the models do not ignore spaces. Therefore, I say it's crucial. They are often included as a part of the next token rather than being separate token. I say it's a separate token, but they are often included as a part of the next token. Just an example, there is an space AI. It might be different than without space AI. This is just an example.
Social.
Sorry?
I think someone's mic is
¿Verdad, Ernesto? ¿Andarai o no?
Yeah,
just
probably. Yeah,
alright.
thank you. And then the
Yeah,
other
thank you.
thing that, and last thing, in many tokenization systems, a space at the beginning, generally at the beginning of a word, affects the token, the terminal. What's the terminal technicus? It is representation. I mean the token representation. It's called token representation. Just an example: space AI and applications without space before applications might be two separate tokens rather than without space AI and with space applications.
Mhm.
Okay, but in that case, so you basically have to double the number of tokens you have, right? Like for every word, you need to have the same word, but with a white space at the beginning.
Yeah, sure. I mean, like I said, each segment of the sentence is highlighted with different colors in the sentence. It means it's representing individual tokens. And spaces and
The,
special
the,
characters, not just spaces, but special characters as well, can be separate tokens.
If you switch
Can you click
token
in
ID, yeah,
token
if you click
IDs?
token IDs,
Or,
you will see different IDs for the same.
a
let me
little,
see.
yeah, there.
Where's the sorry, the Zoom thingy button.
Yeah, exactly there.
So yeah, we have two different tokens.
All the same word,
This,
but with and
yeah. Mhm. Nice. Yeah. So yeah, they're considered different tokens. The one without space is one, and the one with the space is the same. Cool. Rodrigo.
It is like a human language. Some languages have no space in the morphology. For example, I'm not sure, but for example, Japanese has no space in the sentence. It is morphology of the sentence. But some languages have space, comma, etc. They have different morphology. It is like a human language.
Yeah. Rodrigo, I see your hands raised.
Thank you, everyone. Just to point out there, I mean, this is a great discussion. Another point of it there is that it's really understandable where a word, I mean, a sentence start and what is the continue one, right? So at the very beginning, there is no space, and this helps the whole transformer just to understand that when create start a sentence, of course it can be start with this type of words, right? So that creates a hush, like the dictionary of a starting words that helps to start um the whole sentences. So just as reference as well.
Yeah. Nice discussion. I'm glad that we figured out the mystery between the tokens. All right. Then, where was I? So yeah, we talked about autoregressive models, mask models. We're gonna focus on autoregressive ones because they are the ones that are leading the most of the AI revolution with their generative use cases. Yeah, they're slightly a bit more popular and interesting. But just bear in mind that some tasks uh, don't need autoregressive models. Sometimes tasks can be solved with mask language models, and some other tasks can be solved with traditional machine learning. So whenever you can, go back to traditional machine learning and solve it that way. And some other tasks might not even need machine learning at all. So if you don't need it, don't use it, don't overcomplicate your life and just solve it in the traditional way. And just as a side note. So what else do we talk about? We talk about self-supervision, which is something pretty cool about large language models and something that kind of save us some time. Because LLMs, they can be trained in a self-supervision manner. What does that mean? That means that we don't need um, labeled datasets as labeled refer to the traditional way that we used to do things in machine learning. That you had, for example, a transaction, a bank transaction, and you need to flag it as fraud or not fraud. So an analyst had to look at the transaction, I don't know, run some analysis, and then come up with a label that is like, oh yeah, this was a fraud, or no, this was not a fraud. And then they collect like thousands and thousands of transactions like that. And then a data scientist goes and models this problem, these use case, and tries to come up with a model that is able to tell if a transaction is fraudulent or not, just based on some data, some inputs. In LLMs, we don't need to go and manually label everything, because since we're modeling text and we're modeling text in a way that we want to predict the next word, then just by giving, for example, an AI model this context with supervision, then the label in this case would be the word label. So it kind of auto labels itself, given the way that we want to model language is by just completing the next word. We don't need to go and label everything. So that's the idea of supervision, and that's the idea that like this kind of thinking is what brought us here. Otherwise, it would be too time consuming to just go and label a data set to teach LLMs to write. So yeah. I think I saw there was a comment. All right. What else? Yeah, some differentiation between self-supervision and unsupervision. Yeah, don't confuse them. They sound kind of similar, but in self-supervision learning, the labels are taken from the text, and in unsupervised learning, you don't need any labels at all. You just go and mine the data and try to figure patterns, the patterns that are there. Yeah, then we talk about how large language models are measured, and what is considered a large language model. So we talk about parameters. If you have been exposed to the internal workings of a large language model or a neural network, doesn't need to be about a large an LLM. You've probably been exposed to this thing called parameters, sometimes referred as weights as well. And it is these knots that have to be tuned in a language model. And how many knots do you have is how many parameters you have. And it basically gives the model lots and lots and lots of flexibility to tune to fit the data and understanding. So before, like, I don't know, the first neural network, the perception had 3 parameters. Then we started talking in 2018 about millions of parameters, and that was crazy. That was like, what? But nowadays we talk about billions, right? So things just scale very quickly. And that's why now language models are called large language models. And we talk about the going from large language models to the foundation models. And let me see, let's quickly go. Yeah, so large language models. Let's think about first models from OpenAI with billions of tokens, and then foundation models. We kind of start thinking about models that not only work for text, but they also work for other stuff. For example, videos, understanding protein structures, understanding images, as well as understanding language. So this basically is like they start incorporating additional modalities and being these modalities these other kind of stuff. So yeah, for a while, NLP was a thing, computer was another thing. You needed very different backgrounds to work on one on the other. They rarely mixed, and nowadays we have an intersection. Nowadays, you can work with you can use large language models to work for computer vision models. So it is also something that is pretty amazing. And this is the thing that has been allowing us to create these foundational models that will soon have a definition around here, if I remember correctly. Let me quickly see. Yeah, no, that's everything I want to say about foundation models. Yeah, they basically allowed us to move from one task-specific model to general purpose models. So nowadays, you can just go to ChatGPT, ask it to summarize something, ask it to translate something to another language, ask it to generate an image. You can upload an image and ask it what's the text inside the image and stuff like that. So now it's not only a large language model, it's also called foundation model. And then we move from there to AI engineering, which is this all engineering glue that puts everything together and tries to build something that you can put in front of users, basically, and ideally solve a problem, a business problem that saves people some time, makes lives better, saves some money, etc. So, first, let's start with definition. AI engineering it refers to the process of building applications on top of foundation models. So let's always remember that it's on top on foundation models. It's not specifically about building these foundation models. The book leaves that to the machine learning researchers, the data scientists, basically the machine learning engineers to build these models, and the AI engineering ideally knows about how they work, but the head of the AI engineering is also comes from a nice background of computer science, of software development, that understands AI and is able to put the solution together. So we talk about three factors that created the conditions for AI engineering to born. So basically, one of them was that nowadays we have general purpose AIs. We have AIs that can do a bunch of things, like we said. There's lots of money put into building better AI applications, better AI models, and it's now easier to use these AI applications. So, given these three factors, we saw this new discipline that's nowadays called AI engineering, and we required people that knew software development, that understand AI models, and that were able to move quickly and build solutions. Any question before we move to the next section? Now take a sip of water. No? All right. Then we talk about use cases. You probably know coding. This is a very popular one. One of the biggest from what I can see, but of course I'm very biased because we work on this and we code. So we got a lot of help from AI assistants to code, writing, video, etc. There's lots of use cases. I don't know if in your companies you start using AI to automate some stuff, to organize some data. Yeah, it's everywhere. Yeah, as we see here, coding is also a big one. Of course, this fall probably comes from this investment firm that also invests a lot of money into coding. But nowadays, like I just go in the street, I go to a restaurant and like there's people talking about ChatGPT, and before you never saw people talking about in a restaurant talking about support vector machines, right? It's not like you go on to McDonald's and people are like, yeah, did you see the latest release on, I don't know, support vector machines? They can now discriminate between the two classes. It's like, no, right? But nowadays we go and they're like, yeah, AI, it's crazy, right? I don't know. I asked it to summarize some notes from a meeting in my work, and it just saved me 2 hours. And nowadays it's something that is normal for people, and that's great, right? It makes our job more interesting. Also a bit scary how much hype there is around it, but it's fun. Yeah, many use cases. We probably know about them. Education is a big one, also controversial one. The many schools, conversational bots, information aggregation, data organization, automation, etc. Then we start talking about something a bit more applicable, and it is also kind of the introduction to the following chapters. That is, okay, you're interested about building an AI application, right? How do you plan one? What do you do? What do you need to do to actually follow a good path to put one of these applications in production? So Chip goes and tells us, hey, evaluate your use case. Check like when should ask yourself some questions. Like what would happen if you don't build this tool for companies that makes like, okay, if we don't embrace AI, we're gonna go obsolete. So that's probably a good sign that you should build it. If you don't build it, you miss opportunities and profit and productivity. So that's another sign that you probably should invest some time in it. And then other stuff like you're unsure where AI will fit into your business yet, but you don't want to left behind. That's also many companies are in this stage. What else? I don't have many highlights here. I think let me move back. Okay, yeah. We're here planning, use case evaluation. then kind of thinking about how humans and this application that you have in mind, how they will like interact, how they will, what is the role of the AI with the humans. Uh, if it is kind of be like a chatbot that is reactive, or a tool like Google Maps that is proactive, it's gonna be something that needs to be updated constantly, like Face ID, or something that you can train it kind of once and be okay if you don't retrain, for example. For example, here is Google Photos. So I don't know, for example, a mock. Uh, if you train an AI on thousands of images of mocks, probably that's enough, right? Because glasses mocks are not gonna change that much. Uh, but people faces, uh, they change, right? Like I might get a haircut, I might get new glasses, I might add some makeup, etc. And the AI needs to adapt the kind of dynamic in that sense. So that's one thing to consider. Then thinking about if you want to have an AI product, you also need to think about what is the thing that is gonna defend it, right? Since now the bar is so low to build AI applications, that means that there's thousands of people with the right skills to just put one in front of users. So let's say you build something that is a ChatGPT wrapper. Um, Somebody else with a ChatGPT API and some coding knowledge can create a solution like yours, right? So now you need to have some competitive advantages, right? You need probably to have, you might need to have a better technology. You might need better data or better distribution. If you have the three of this, you're probably gonna get very rich. Um, if you have one of these, you have chances to get probably acquired by a richer company. If you have none, then your odds to success are probably very low, and someone will do something better. So this was also important in not just AI products, but just products. Uh, same idea applies to also software products, right? You need to have good tech. Probably the data part was not there, and the distribution, yes, the distribution is always an issue. So yeah, now with everybody being able to develop AI applications, you need to have at least one of these covered. And something else that it was pretty fun, pretty interesting that Chips mentioned is that with AI, it's very easy to create a very, very good first demo, right? Let's say I have a use case, uh, and I'm gonna spend 4 hours, 2 hours working on it to see the feasibility of solving the problem, and I just connect to ChatGPT, do some first iterations, and I get a nice first result. I show it to my boss, to the company stakeholders, etc., and they're pretty excited, pretty happy. But moving from this first result to something that is usable by people outside of our company, it's very hard. That like to go from that step to final product, uh, it requires a lot of additional things. So it's very easy to have high expectations after the first demo. So something that Chips mentioned is that a good initial demo doesn't guarantee a good end product. So it's something. Oh, also something to bear in mind when pitching AI applications to friends, to bosses of your company, uh, to have that in mind, right? And yeah, then we start talking about the AI engineering stack, um, the application development stack, the model development, and the infrastructure. So this is very close to software engineering. This is very close to machine learning engineering or data science, and this is very close to also ML engineering or data engineering. So of course, an AA engineer might not know everything about all these three layers, but they know enough of each layer to move around. As I said before, many of the principles of AI application remain the same as in ML engineering. And then we discuss a little bit about the difference between one and the other. So AI engineering focuses less on modeling and training and more on model adaptation. We will see what model adaptation means in the next chapters. AI engineers work with bigger models, so they need more GPUs. AI engineers deal with open-ended output models. So, for example, yeah, a generative model that just outputs text. Uh, it's not like the common use case in ML where you ask the system to predict if the transaction was fraudulent or not. In that case, the output is not open-ended, right? We only have two types type of outputs: fraudulent, not fraudulent. In AI engineering, the output can be a single word or a huge paragraph, right? And we need to evaluate both. And we need to come up with measurements to know if the AI model is good enough or not to put into production. So a bit more challenging. Then we kind of understand that ML engineering starts from data, model, and then we have a product. And AI engineering, it's kind of the other way around. We go from product to data to model. And that's it. Those were all my notes, my comments. I don't know. What did you think about this first chapter? What are your impressions? Anyone?
Yeah, it like seems like a good starting point, and it's covering holistically most of the aspects of uh, software and ML engineering too. So yeah, that kind of yeah uh, looks like a good uh, overview, and I think so. In the following chapters, we will get into the details of how the methodology and the uh, like the end-to-end chain kind of works,
Mm-hmm.
and how can we uh, take from inception of a research product, a research project into like productionizing into and serving it to multiple people. So I think so we will cover everything. So yeah, that's this kind of seems like a good start here.
Carlos, go ahead.
Um, to me, something that was interesting about the book is that I've been thinking a lot for this last something like about a year or something like that, because I don't have a machine learning job. I work with regular software development. And I always thought of this AI thing like a shift in my career that was going to be so big that I was going to have to somehow throw up everything I know. But this book, especially this
Mhm.
first chapter at the end of it, it kind of tells you, well, if you have these skills like full stack skills or something like that, don't throw them away. It's now there is this there is these two different branches, machine learning and AI, according
Mhm.
to its vocabulary. And in this AI layer, where you're meant to create applications, those skills, like regular software skills, are going to be useful because you need to be able to create demos quickly, and you're going to have to expose things to the web. So whatever you know, if you know Vue or React or whatever JavaScript framework or something like that, it's going to be useful. Yet it's just about to connect them with the foundation models and see how you exploit their possibilities.
Yeah, yeah, yeah. That's pretty cool, right? Because yeah, in machine learning, people were required to know a little bit more about machine learning than about software engineering. And now with the engineering, it's like, okay, if you come from a software engineering background, then it will be easier for you to pick this field, yeah, to enter this field. Mesut.
Yeah, thanks for your efforts, and it was actually great. I haven't finished the first chapter yet, but I write something about the first and two chapters later in the week. I'm DevSecOps engineer for years and already planning to switch to AI somehow. And I still have some question in my mind, for example, about the last part of the section. I see here ML engineering and AI engineering, and then we discuss actually almost every day the difference between ML ops and AI ops. The
Mhm.
reason is I am DevOps engineer, and then I use some dev and then ops environment tools, libraries, etc. What will be my next title in this area? I mean, is it AI ops or ML ops? What is actually distinction between AI ops and ML ops? Is it same thing? I mean, ML engineering is ML ops engineering, or and AI engineering is AI ops engineering. If someone use AI products, it's called actually AI ops. It is just using of something. But
Mhm.
if someone develops something with AI environments, tools, platforms, etc., it is actually ML ops. Is it true, or what do you think about it? Thanks.
Yeah, I think that discussion, like Chips discusses that briefly, as also part of the reason why she called this book AI engineering and not, for example, AA ops or LLM ops or anything else. Uh, I think these all of things are often very like vague and open-ended, and then it's the industry kind of starts using more one than others, and that's how the term sticks. But yeah, I don't have any strong opinions in my. I think by the end there's something. Um, yeah, maybe anybody else has an opinion about this type of job descriptions.
Um, I have a comment on
Mhm.
this thought that having being a full stack engineer is really beneficial. I
Mhm.
kind of question whether in the long term that really is beneficial. That if you could imagine an agentic workflow where the final agent is an agent that specializes in framing the conversation in some sort of UI UX code, where it's not really necessary to have that individual who's has those capabilities of a full stack engineer. I just wonder how long that will be beneficial, especially when you get models now increasing their capabilities in coding. I'm not saying that's going to happen overnight, but I wonder, as a full stack engineer myself, I'm sure lots of coders are wondering, are they going to have a job in the next 5 years?
Hmm.
That's it. That's my only comment on it or share.
Yeah, I
Yeah.
agree. But what I would add is simply that these models are starting to be useful, and the first language that they are learning is Python. So it's also going to affect the other jobs, like machine learning jobs or other tasks are also going to be affected by whatever the agents can do. But my take on this, and it might be a wrong mistake and it might be proven to be a mistake in the next years. But my take at the moment is that we need to understand what the machine does. So if it creates Python code to create a neural network in PyTorch, then you need to know PyTorch to read the code and know that it does what it's expected to do. And in the same way, if it creates a React application and it does more or less what you need, but then you need some adjustments, you probably want to be able to do them. So
Hmm. Yeah. Yeah. My take is similar to Carlos. Uh, and in my opinion, if you're able to understand the under the hood of the things, then your odds to be safe are increased. That's one of the reasons why I named the reading group AI from scratch, like the scratch part. Like this book doesn't have a lot of scratch, but the scratch part is essential for me, and I think it's what it might differentiate between a great engineer, a great data scientist, a great AI engineer than 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 a regular one, than one that their odds are high to be replaced. Right? If you understand the fundamentals, you can then adapt quickly to whatever comes next. That's the idea. That's the idea. The other day, I was watching a video, and I forgot the YouTuber's name. But they were saying if if your job is only to be like in the supply chain between the model and your IDE and the code where you're coding. Like if your job is just uh, copying and pasting what ChatGPT outputs, pasting into the IDE and click run and cross your fingers, then the odds for you to be replaced are quite high, right? Your job is just copy and pasting between one and the other tools. But if you actually understand what is happening and you continue uh, exercising that coding muscle, uh, uh, you'll probably be fine. Uh, so yeah, even if we have coding assistants and they are good and everything, in my opinion, be careful how much do you use them because coding is a muscle. So make sure to continue training that muscle, right? Uh, that's yeah, that's
Yeah, I think so. I agree with Carlos here. And coding is a muscle, and like, uh, yeah, these sort of like regular uh it's not like LLMs will replace us. It's like we have to learn to use it to an optimal advantage so that the boilerplate and the menial kind of code writing is taken care by LLMs, and
mhm,
kind of system integration and complex logic is
mhm,
to be taken care by the humans. So like it's a mixture of how do I say it? Like a junior engineer with a senior engineer. So you can kind of look at like this way. And yeah,
Hmm.
I think so. Howsoever people uh, kind of get familiar and get their hands dirty and yeah, choose that stuff. So yeah, it would be beneficial for like those folks who are doing that in the long run.
Hmm. Yeah, there's also this other perspective that is like AI is not going to replace us. It is humans that understand AI, the ones that are going to replace us. Like,
Yeah.
I bet that that's also why we're all here. We want to be one of those humans that understand AI. Rodrigo, go ahead.
Yeah, just another point over there. The market changes every day, and the needs change every day as well. So what this means is that at the end, probably an LLM, such as all those that we know, will not have that flexibility to understand the market at this point, right? So I think that having that skill, being criticized as being humans, um, makes the difference, right? Just to taking both the skills, as Carlos mentioned, having the skill of development and having the skill of machine learning or the whole AI thing makes that people really as an unicorn, as I call them, because is that person that able to create things, create new things, solve new issues that come into the market that requires solutions, right? So if that person, just as Santiago mentioned, knows everything from scratch, is able to understand how to solve that issue in faster manner, and it will be impactful for the society at the end. So we cannot forget how the market moves and how the necessities through the world are changed every day.
Neat.
Something
All
that
right.
also caught my attention, that is kind of in the line of what we're talking, is that it's very logical to understand that Python has become the most used language nowadays, the most popular one. Uh, but something that surprised me is that C++ is also growing
Mhm.
super fast, and there is a reason for that. The reason is as we have more languages, more machine learning projects, inference optimization becomes also something that is needed. So we need people who know how to do that. So I think that learning how to keep these models running is a thing. And I agree with the worries that I think we all have those worries. Like we don't know where this is coming, where this is going, because in the next years, these machines might be super good at creating optimized code in C++. So maybe it would be something that is actually not that needed. But as of today, we need to at least supervise what they are doing, and it's not enough to supervise the language that they generate. We need to supervise all of the tasks. So
Yeah. Yeah, it's fun. I think I've never just personal comment. Uh, I never had like any formal education on C++, but something I'm doing now on the side just because it looks fun. And I also want to not just be in the end of, okay, I know how to develop models, but now also want to build, understand how they build faster ones, how they make software, optimize their software. So yeah, quite nice. We're very close uh, to the 90 minutes. I just want to thank you everybody for joining. This was great. Hope this was great for me. I hope that it was great also for you and not too boring. Uh, maybe we should well, maybe no, we should assign the next leader. So are there any volunteers that want to take on the next chapter, which is understanding foundation models? Anyone? Your job would be basically lead the discussion as I try to lead it today. And you can make it as I did, just scrolling through the book. You can make a presentation. You can just bring some questions that we discuss. But the idea is to have someone that lets it. Anyone. Not everyone. No?
Okay, I'll do it.
Don't be shy. Yeah, Carlos, great. Nice. Carlos.
Nice job, Carlos.
Yeah, thank you, Carlos. So yeah, anything else before we drop off? No? All right. Then thank you. Like I said, this was great. See you next week. And yeah, have a good rest of the day.
Have a nice week.
Enjoy.
Thank you.
Thanks,
Have a
everybody.
good day,
Bye.
guys.
Bye.
Thank you. Bye. Take care, guys.
Bye.